Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on buck boost converter. Here, this is the definition. Here, buck boost converter means here buck boost converter. Buck boost converter is a type of DC to DC converter. We can use it as a boost converter and buck converter. Sometimes in case of boost converter, here high voltage output voltage is here greater than Vs, and in case of buck converter V0 is less than Vs. So we can use this converter as a boost converter and buck boost converter and buck converter. Here the buck boost converter. Now here the diagram for buck boost converter is supply voltage and output voltage and one switch and one inductor and one prevailing diode and another one is a capacitor. These are the components used in the buck boost converter. So first here what are the parameters you need to derive. First one is when switch is on, calculate the voltage across the inductor and current flowing through the capacitor, VL on and IC on. So now here when switch is off, so what about the inductor current, inductor voltage and capacitor current when switch is off. So IVL off and IC off, and volt second balance. What does volt second balance? VL on plus VL on T on, VL off T off is equal to 0. This is volt second balance. And next, what about ampere second balance? IC on T on plus IC off T off is equals to 0. So this is volt second balance. And next, what about the ripple in the inductor current IL? So what about this one? IL del IL, and next IL maximum, IL minimum, source current IS, and switch current ISW, and diode current ID, and ripple in the capacitor voltage, that is del VC, and at what duty ripple is maximum. So in that case del VC is maximum, and critical inductance LC and CC means critical capacitance. So now in the buck boost converter, so now calculate the VL on and IC on when this switch is on. So when switch is on, this is the case. When switch is on. So now here in this case, so what will happen? First here VL on equals to, so VL is equals to Vs only. So this is the case. So this is plus and minus and plus and minus. So VL on equals to Vs only. And next case IC on. So IC on means here IC on equals to, there is no current here, so IC equals to minus I0 only. So now IC equals to IC on equals to minus I0. So this is the formula. And next here when switch is off, calculate the inductor voltage and capacitor when switch is off, capacitor current. So now here this is open circuit. This is open circuit means here this is VL and this is the output plus and this is plus and plus. VL off equals to V0 only. And next here inductor current is flowing through like this here only. So now this is I0, this is IL, and this is the this is I0 and this one is the IC. So now here if you apply KCL in this, so IL plus IC plus I0 equals to 0. Now IC equals to minus of IL plus I0. So now here this is IC off equals to minus IL plus I0. So this is the, now we calculated the when switch is on, VL on is equals to Vs and VL off equals to V naught, and IC on equals to minus I naught, and IC off equals to minus IL plus I naught. So this is the case for when switch is on and when switch is off. So now here, what does volt second balance VL on T on plus VL off plus T into T off, so that equals to 0. Now this is Vs into dt plus V naught into 1 minus d into t equals to 0. From this we can calculate that equals to minus d V naught by 1 minus d into t. D is in between 0, d into between 0 and 1. So now this is the case for output voltage. So minus duty cycle d equals to T on divided by T on plus T off. So that equals to T on divided by total time period. So now this is the output voltage. From the volt second balance you can determine the output voltage V naught is equals to minus d V naught by 1 minus d. So now here second ampere second balance IC off on plus IC on T on plus IC off T off is equals to 0. So now here IC on means here what is the IC naught minus I naught plus I naught into dt plus minus of I naught plus IL into dt is equals, sorry, not dt, 1 minus. Turn off means this is 1 minus t dt and this is the dt. So now here this is 1 minus d into t is equals to 0. So now here minus I naught dt minus, so now here you need to calculate this IL of dt. So minus I naught into 1 minus d into t plus IL into 1 minus d into t is equals to 0. So now here what will happen, first here minus I naught dt, so minus I naught t plus I naught dt plus IL into 1 minus d into t is equals to 0. So now this is positive and this is negative, so it will get cancelled. Minus I naught t plus I naught into 1 minus d, this is not minus, this is minus, and this is t is equals to 0. So now here what will be the value, this is minus, so this one is also, I think this is minus, and this one is a minus. So here t is minus I naught is equals to, so this is I naught, this is IL, and IL 1 minus d into t. T gets cancelled here. So now here IL equals to minus I naught by 1 minus d. So this is the inductor average current. IL equals to minus I naught divided by 1 minus d. So now here IL average equals to module of I naught by 1 minus d. This is the case for ampere second balance. And next, ripple in the inductor means same as in the boost converter. So when during the on condition, this supply voltage VL on equals to supply voltage. So now here L di by dt is equals to Vs, same as in the, so this is on. So now here L into del IL divided by, this is during on condition, that is Vs. So now here this is, so del IL equals to Vs into d into t by L, that equals to d into Vs by F into L. So del IL equals to d into Vs by F into L. This is the ripple in the del IL. So ripple in the inductor current equals to d into Vs divided by F into L. So now this is the IL minimum and this is the IL maximum and this is the IL by 2, del IL by 2, and this one is a del IL by 2. This is IL average. So that equals to magnitude is equals to I naught divided by 1 minus d. So now here IL maximum equals to IL minus IL minus del IL plus for IL minimum equals to IL minus del IL by 2. So now here in the previous one del IL by 2. So now here is also same IL minimum, IL maximum. So this is IL. So now this one is del IL by 2 and del IL by 2, and this is total del IL by IL equals to D into Vs divided by F into L. So now next case, here source current equals same as P input equals to P output. So that equals to P input means V naught Vs into Is, that equals to V naught into I naught. So now here Is equals to source current equals to V naught into I naught divided by Vs. So this is the formula already we have seen in the boost converter. And what about the switch current? Switch current means same here, ISW average and next ISW RMS value. So that equals to IL average into dt by during on condition. If suppose this is the inductor current IL value. So now when switch is on, so switch is T on condition only, inductor will switch will on. So inductor only, inductor current, that is, so that is I switch current when switch is on. So now here that is during T dt time only. So dt time divided by T and IL average dt by T. Substitute IL equals to, in all the case IL average is equals to magnitude of I naught into 1 minus D. So take this formula, and next here I switch RMS equals to, RMS is equals to I average, IL average into square root of dt divided by T, that equals to IL average square root of dt. So that is IL average into D. So this is for average, this is for RMS value. And next, what about diode current? Diode current means when switch is off, so average inductor current. So 1 minus dt duration, when switch is off you will get the inductor current. So that equals to ID average equals to IL average, and that is 1 minus D into T divided by T in the during off condition total time period T, and IL ID RMS equals to IL average into 1 minus D into T divided by T under root. So now here ID average equals to square root of 1 minus D. So this is IL, so ID RMS, and this ID average value equals to IL RMS into 1 minus D. So this is the case. So now diode current and average value and diode current RMS value. Ripple in the capacitance means same. What will be the value here? So del Vc. So del Vc means here same, here during on condition. So what will be the value here? This one here minus I naught equals, sorry, IC equals to minus I naught. So now here minus I naught means here IC means C dVc by dt is equals to minus I naught. So now dVc by dt equals to minus I naught by C. If you integrate it, del Vc dVc, and this is V maximum to V minimum, and next here this is dt 0 to dt minus I naught by C. So now here you will get del Vc, sorry, V minimum to V maximum, that equals to minus I naught by C, means here minus I naught by C into dt. So that equals to C. So that equals to here minus del Vc. So now this is a ripple in the voltage. So that equals to minus I naught into dt by C. Del Vc is equals to I naught into dt by C del Vc is equals to I naught into d by Fc. So this is the case for ripple in the capacitor. So ripple in the inductor. Now I naught equals to V naught by R. V naught equals to, what is the formula? Minus d into Vs by 1 minus d. Substitute in this. So this one. So you will get another one. So that is this one. And next here, duty cycle. So now here, so del Vc is directly proportional to the d. So now here del Vc is directly proportional to the d means, so d value is in between 0 to 1. So at maximum value means d maximum value is 1 means at 1. So del Vc is ripple in the voltage is maximum at 1 only. Now here critical capacitance. So how you will calculate the critical capacitance here? Critical capacitance here. Critical capacitance means here the definition for inductance, the minimum value of inductance. So for which inductor current just become continuous. So IL minimum is equal to 0. IL, that means here IL minus IL del IL by 2 is equals to 0. IL means here IL average means equals to I naught by 1 minus d, that equals to here this one is equals to del IL by 2 means here d into Vs by F into L. This is the critical inductance. So now this one equals to minus V naught by R into 1 minus d. So now here V naught means here, so V naught equals to this one equals to here, this one equals to minus V naught means here d into Vs divided by 1 minus ds into this R into 1 minus d, R into 1 minus d. So now here 1 minus d, this is the V naught. So now here this dvs gets cancelled, and this LC is equals to this, this is R here, this is R is here. So now this LC equals to 2, FR. This is 2, and this one is 2 FR, and next here 1 minus D. So 1 minus D whole square. 1 minus D whole square. Here 1 minus D into 1 minus D into R. This is R by 2F. This is the formula. 1 minus D square into R divided by 2F. So now here critical capacitance equals to here, what is the formula? Del Vc is equals to V naught minus, so del Vc minimum is equals to 0, and del V naught minus del Vc is equals to 0. The minimum value of output voltage just becomes continuous. Del minimum Vc minimum is equals to 0. V naught minus del Vc equals to 0. So now here V naught minus del Vc means here I naught into d by Fc is equals to 0. So now here I naught equals to, what is the value? So now V naught equals to minus V naught by R into d by Fc. So now here C equals to, so V naught gets cancelled. Fc equals to d by, so this is divided by 2. So now this is 2, and this one is the 2, and 2F into R, d by 2F into R, same as in the boost converter. So now if you see the formulas here, this is d by 2FR, d by 2FR, and this one is a 1 minus d whole square into R by 2 into F. So now here VL on is equals to Vs, and VL off equals to V naught, and this one is the minus I naught, and this one is the minus of IL plus I naught. So now from the old second balance, V naught equals to minus D into Vs divided by 1 minus D. And next here from the this one, I naught equals to IL equals to minus I naught divided by 1 minus D. Now ripple in the capacitance in inductor current equals to what is the formula here? Del IL equals to I del IL equals to D into Vs divided by F into L. So now same as in the boost converter. Now IL maximum, IL minus IL plus del IL by 2. Now this equals to IL minus del IL by 2. Now source current equals to Vs I naught Is into Is equals to V naught into I naught divided by Vs. So now substitute in this the V naught I naught Is, and next IL I switch average equals to IL average. So IL average you can substitute in this, so that equals to D, and next I switch RMS equals to, so IL average into square root D, and next diode current equals to ID average equals to IL average into square root 1 minus D, and ID RMS value equals to IL average into square root of 1 minus D. Substitute IL average value is this much. So take modulus, and next ripple in the capacitor voltage equals to what will be the value? So I naught into D by F into C. So now this is del Vc, and next here duty cycle at D equals to 1 only, means del Vc is directly proportional to D value is in between 0 to 1. So a maximum value of D means that is 1. D equals to 1 only, the ripple value is maximum, and this is the case for critical inductance, and this is the case for critical capacitance. I hope all these concepts are clear to you regarding buck boost converter. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.